instead of posting last year's first exam to the Angel website, what I did instead was I printed out copies of it. The reason for that is I looked back on last year's first exam. What I had done is I'd hand-drawn some of the circuits on there. So if I posted it electronically, you might not have picked some of that up. So I printed out everybody a copy of last year's exam 1, and I'll pass that out again towards the end, and we'll see how much time we have. Maybe we can go through a question or two with that. All right, so I'm going to start. Well, maybe the last 4 or 5 classes I've been starting with a real-world application. I suppose this is a real-world application, but it's right on topic of what we're doing. So it's not really a review question. I'm going to start with that useless circuit that we built last class. The useless circuit that we built at the end of last class was a circuit involving an op-amp. What is op-amp short for?
Operational.
Yeah, okay. So it's some device, and with much drama, we connected the output back to one of the inputs. And what I just did there in 2 seconds, we took 20 minutes to do last class. We talked about feedback in everyday life, examples of positive feedback, examples of negative feedback. And here what we're doing is we're connecting the output of a circuit back to the input of a circuit. And that idea it is an important one in engineering, not just in circuits, but the concept of feedback, that the output of your system might go back to the input is an important thing to be able to study. So in this example, this was an example of negative feedback. This circuit would tend to stabilize at a particular voltage, and of course, if I applied some voltage of maybe 5 volts here, then we looked at this circuit, and we looked at it carefully last class. Let's go through it again real quick. Suppose this started off at 0 volts. Everything was 0. Suddenly plugged in. No problem. We've got it on camera. If everything starts off at 0, and I suddenly turn that up to 5 volts, what we did was we walked through the circuit to see what the circuit would tend to do. Let's make that plus 10 volts and minus 10 volts. If this voltage is bigger than that voltage is going to tend to try to get higher. It can't go from 0 to 10 volts instantly. So we can slow down the clock and look at the slow motion version of it. So maybe it just gets from 0 to 1. Then that goes to 1 volt. The 5 volt is still bigger than the 1, so it's still trying to go to 10. So it'll get to maybe 2. That becomes a 2. 5 is bigger than 2, so it's still trying to go to 10. So it goes to a 3. 5 is still bigger than a 3, so it goes to a 4. 5 is still bigger than a 4, so it goes to a 5. And when it gets to a 5, 5 is now a tie. Now, suppose, in the unlikely event, bless you, it's exactly a perfect tie. In the case of a perfect tie, this op-amp tries to take the difference between those two, multiply it by a huge number. So it'll take the difference between those two, which is now 0. It'll multiply it by 1,000,000. 0 times 1,000,000 is 0. So this is going to try to make the voltage go down to 0. So it got all the way up to a 5. And then once it gets to a 5, it'll try to go back down again. But as soon as it goes down, even the teeniest little bit, as soon as it goes from 5 down to 4.9, now this is bigger than that. And when the 5 is bigger than the 4.9, it tries to push it back up again. So this will stabilize at 5 volts. And that's an example of negative feedback, because if this goes lower than 5 volts, the op-amp tries to make it bigger. What happens if this goes bigger than 5 volts? Like, what if it becomes 5.2? So if that becomes 5.2 volts, then the positive is bigger than the negative, and the op-amp is going to try to, what, increase the voltage further or lower it? Lower it. In fact, it's going to try to put it to negative 10. It just can't get there instantly. So if it goes bigger than 5, the op-amp will try to lower it. If it goes lower than 5, the op-amp will try to raise it. So it's a perfect example of negative feedback. It's just like you driving down the road with your car. If you get a little bit too far to the right, you turn back left. If you you get a little bit too far to the left, you turn back right. That's very different than imagine someone driving their car in positive feedback mode. What that would look like is as I drive down the road a little bit, if I get a little bit to the right, I turn to the right. And if I get the more I get to the right, the more I turn to the right. So that driver doesn't last very well. I suppose they can start pointed straight, but as soon as anything goes wrong, a teeny little bit, they hit a teeny little grain of sand on the road, so the car bumps a little bit to the right. Now the person turns more to the right, so they turn more to the right, so they turn, and eventually they'll just spin out. So don't go driving with that 16-year-old. So this circuit is a fancy circuit that takes the input voltage and will produce it at the output voltage. There would be an exception to this, of course. Suppose the input voltage were 20 volts, then the op-amp will not be able to get to 20 volts as an output. This is the largest largest voltage is able to produce. That's the most negative voltage is able to produce. So if I put 20 volts at the input, the output is only going to be able to produce up to 10 volts.
What's the actual purpose, are you going to get into that, of doing the, okay.
Well, I'm going to show you a circuit where this useless circuit actually does something important. First, I wanted to reintroduce the useless circuit. Explain that it's actually worse than useless because it doesn't even perfectly do what it's supposed to do. It doesn't perfectly take this voltage and make it that voltage. It only works if that voltage is between these two supplies. Matt, do I have you? Yes. Okay. So, before I draw a example where this could be useful, let me just clarify something that we've clarified a couple times, but it's worth clarifying again. This is the first time this semester I'm not drawing a complete diagram. I'm putting a plus 10 label up there. What I mean by that is some plus 10 voltage source with respect to the reference. Here this 20 volts means some 20 volt voltage source connected with respect to the reference. Negative 10, same thing. Some negative 10 volt source with respect to the reference. So everything is measured with respect to a reference. But you can see, look how complicated that picture becomes. So I'd like to just not draw all these different voltage sources on the picture, but instead just label them with a number. And you have to know, though, that what that means is some voltage source connected compared to the reference. Okay, suppose I wish to construct a guitar amplifier. I'm going to use this useless circuit to do that.